Hello, world. Welcome back to Let's Code. I'm super happy that you joined right now, or perhaps maybe you have a look at this recording later on because I will put all of the recordings in the next 2 weeks on the YouTube channel. But I will announce that in the next session in 2 weeks. For now, let us code. So today we are going into the next episode with source generators. Last time, we have upgraded an existing project from Roslyn 3.8 source generators to the newer Roslyn 4.0 incremental generators, where we have discovered a potential performance issues for big solutions, for huge solutions with the source generators, and utilized the programming model of incremental generators to mitigate that. So let's have a look at today's agenda. We will do a brief recap of what we learned last time. We will have a look at the source code of enum.isDefined, and we will have a look if we could ourselves, well, we can, but how we can create a more naive, non-generic, reflection-free variant, which then is quicker, but only works for one specific use case. Then we're gonna test that and see what the use cases are. So with that data, then we can generate that version or build a generator, which then creates this at compile time for every consumer of this package. We will then, of course, um, unit test this auto-generated variant, also benchmark it, see if this is just as fast as we have initially intended with our naive manual implementation. Then we will see, because at the beginning we will be generating or emitting C#10 code. Maybe we will also support lower language versions so that the consuming project does not necessarily need to be on the latest C# version just yet. However, they still need to be on the latest .NET version, on .NET SDK version, so on .NET 6 SDK, because this is what is required for incremental generators. And at the end, as always, we have a look at both the code coverage and the mutation test report to see how good our tests are. So, what did we learn last time about incremental generators? I will jump into the solution. So we inspected this generator project, and this project already contains 3 generators. And last time we have updated them from source generators to incremental generators. And an incremental generator, if I step into the definition, it's an interface. It's an interface which basically has only one method, the initialize method. This initialize method injects us the incremental generator initialization context, via which we have several incremental value providers. And we use those in order to build up our pipeline, our source generation pipeline. There is also a syntax value provider. This is a more, with the syntax value provider, we can basically create our own incremental value provider consisting of a semantic check and a syntactic check. But yeah, we will dive into this when we implement our new generator again. And then we build up our pipeline where we define all of our steps. And at the end, then have a callback where we actually would produce the source, where we eventually then call context.addSource, which is now really adding C# text to the compilation. So to add this to what the user has written in their project, and then have one combined project. So what we have in this project already is an Enum generator. We jump into this benchmark here. We have here 3 benchmark methods. It's basically variants of how to toString an enum. We here have the log level none. This is from Microsoft.extensions.logging. And we want like to get a string of it. So in the first benchmark, this is the generated version, the enum info.getName. If we jump into this, we see this is generated file and actually cannot edit it. Or if I try to edit it, then I get this notification that this is a read-only file. This is generated. Doesn't make sense to edit this. And here is now our very naive or straightforward way of how to get the string of the log level enum, where we basically switch on this value, check which value it is, and get the name of it. Now there's 2 different implementations in the .NET BCL already. There is the toString overload. Yes, so the overridden toString method, and also enum info just enum.getName, which is a static member on the enum type. And we have a few benchmarks, and I will run them on the side, see what the result there is. So let's run these. With benchmark.net, we always run our benchmarks in release mode. Let's select the benchmark we care about. Let's run this in the back. And what we also have is a set of tests where we confirm that the enum info actually behaves. We have a suite of tests where the enum info actually behaves just as the enum.getName from the BCL, basically confirming that the enum info.getName is basically a generated drop-in or replacement. So if I just write enum.getName, I get the BCL variant. But if I do enum info, then I get the generated version, which is faster at runtime because it's specially compiled at compile time. See how the benchmarks are doing. Still running. So in the meantime, let's have a look at what we will build today. If we jump to the discussion, I will also put this into the chat if you would like to follow along. So we will have a look at this issue where I would like to build a variant to enum.isDefined. This is quite similar to the enum.getName, but the difference is it returns a Boolean if this enum constant is actually defined, and returns false if it isn't. So we can have a look at the documentation of the isDefined method. It says it's a Boolean telling whether the given integral value, because an enum has as underlying type some integral value. Per default, it's an int, so int 32, but it could also be int 64 or a short. I think it could also be the newer pointer integer types, I think. The native, sorry, the native integer and an unsigned native integer. And yes, so if we have a look at there's actually 2 methods in the BCL. One, which takes a type. It takes a type, and object as a value. Now, it takes an object because we don't necessarily know if this enum type actually is the underlying type is integer, because it could be some other integral value. So we're passing an object. This is not the best, because if we put in an integer, for example, a 4 into that, since this is object, but an integer is a struct, we will have boxing there. So this causes allocation. This is not the most performant um, thing. But I believe this was this, perhaps this was even available before generics. And there's also the generic version, where we pass in it's constrained to an enum, so we can only pass in an enum. We cannot pass in anything. So we know, okay, this is a struct, so we have no boxing here. And now let's see if we could do with a naive implementation, because this is a general implementation. This works for any enum which is out there. What we generate will work only for one specific enum, but hopefully this will be then faster. Let's have a look. But first, let's come back to the benchmarks to see. This will hopefully be some similar result with our other method. So the generated version of our enum.getName takes 1.5 nanoseconds. Well, I'm also streaming on the side, so those it's not about the nanoseconds per se. It's about the difference to the other variants. Like, for example, the enum toString is measurably slower, or takes measurably more time, and also has just a bit of allocation. The enum getName has non-allocation, but is even ever so slightly slower. So we are talking about nanoseconds, so this would be definitely a micro optimization. But perhaps in a very specific use case, you could profit from this increasement, from this less runtime needed, and also perhaps avoiding an allocation. And we see this is, I still have net 5. I should upgrade this to net 6 actually. I'll do this later on. And on .NET Framework, we have a similar result. So let's see if we can achieve something similar with the isDefined method. So let's create a new benchmark. I'll call it enum info isDefined generator. This actually tests. Hold on, I wanted to do a benchmark first. Enum info generator, enum info is defined generator. I should actually then rename the others as well to have enum info get name generator, but yeah, I'll do this later on. I didn't foresee that we'll actually be building more enum info methods. So it's a generator benchmarks. A benchmark in benchmark.net always has the benchmark attribute. It's a public method which should return something. In our case, it will return the Boolean. It should return something so that there is no code optimization potentially removing code. So it should be public and returning something so it's not subject to any optimization. Let's call it this is the generated version. And we will make this our baseline. Baseline is true. So let's now naively build it. Let's have our internal class enum info. In that static class, we add a static member. Actually, let's pause there for a second. Let me define the other one first. So this will be also a benchmark, but it's not the only one benchmark within a class can be the baseline. And this would be the system enum is defined, the one from the BCL, where we now return enum dot is defined. So we're also going to have an enum instance. So let's do private. Do we stack it? Yeah, it doesn't matter. Read only. Let's do a log level again. Log level. Log level is, let's do none again. And let's pass it in here. I guess we can make this to an expression body. Yes. And I will now jump into the definition, basically copy this signature, paste it in here, and let's change it to what we are going to need. Since we are not making a general purpose method, but a very specific method, this is not generic anymore. It directly takes a log level, or perhaps let's call it value, because I think this is how it's also called here. Yeah, it's called value. Let's also call it value here. So we have no generic constraints. We don't need them. And what my first naive approach would be is just having, again, a switch on the value. And let's generate the missing arms. And so if anything matches, this would return true for all cases. And if nothing matches in the default arm, we would return false. Okay, so let's call this one return enum. So basically I could copy this from down below, and all I need to add is an info to not use the BCL method, but this not yet generated method. And yes, I believe this is it. Let's have a look how they are comparing. It's run.net, benchmark.net again. Oops. Did I call it get name? Oh no, I have somewhere else a compiler error. Okay, maybe I do need to build. This is from the other type. Why is this not picked up? Oh, I see. Because it's no longer using this one. I need to specifically state the namespace here because I have the same. Actually, I don't want to change that. I want to here just call it info 2 for now. Okay, this should get rid of the compiler error. And we will select our enum info is defined general benchmark. That's number 1. And while they're running, let's add some tests. I'll basically copy this implementation. Let's see if this is actually behaving as the BCL is defined is. So let's jump to tests. Let's here now also create a enum info is defined generator tests. We start with effect, public void generated is defined, and the BCL system enum is defined are equal. Oops, so I will copy here this implementation as well. I don't have a log level here. Let's perhaps use a different one. Let's use string comparison. Perhaps we should also also test it with a flag. What enum is a flag? Attribute usage, isn't it? Attribute, the attribute usage attribute. The attribute usage attribute is an attribute that you put on attributes in order to state on which um, targets this attribute is valid on. So here we say that the XUnit fact attribute is only valid on methods. If I would try to place this on a class, for example, this would immediately give a compiler error. We have here the attribute is not valid on this type. It's only valid on method declarations. And this one is, hey, hold on, this is not the enum, sorry. This is the attribute. I needed an enum, not an attribute. Sorry. This one, the attribute targets. Yeah, this is the one. And this is indeed a flex. So we could combine them. We could allow an attribute to be both placed on a class or on a method or any other target defined here. So let's use this one. Let's have our, this is now an enum. A value, I remove all the arms and again have writer implement those arms for me. Okay. And all of them. Guess there is a shortcut to mark all of these, but I'm not aware of this right now. I do the naive approach. If we hit any of these, it's true. Otherwise, if we fall through to the default, it's false. And let's see how this is doing. If we find a value here, let's say method. We talked about method already. The Boolean system one, we do enum dot is defined as in the value. And also duplicate the line, same for the generated, where this is enum info2 is defined. Do I need to specify the generic here? Not sure what I'm doing wrong. 30. Method boom does not have type parameters. I'm not sure what I'm doing wrong here. It's enum dot is defined. We have passing any enum, and our value is an enum. It doesn't pick up the generic one. That's interesting. System dot maybe enum dot is defined. There we have it. We pass in any enum and retrieve a Boolean. We could say should be able to do this, but we can't. What am I doing wrong? Is it not? Is the project version maybe set to some? No. Mm, do you have the same experience if I try to build it via the CLI? Yes, okay. Yes, the is defined cannot be used with type arguments, but the non-generic method, but there is a generic method. Am I on the wrong target framework where this doesn't exist or something? Ooh, yes, okay. Yes, my bad. In .NET Framework, this method doesn't exist. It only exists in, let's see, since when does this exist? I do multi-targeting here. If we hit F1, we jump to the documentation, is defined yeah, so on .NET Framework 4.7.2, we only have the non-generic version with the type and the object, which does boxing available. If we jump to .NET, we see that the is-defined is available since .NET 5, actually. That's rather new. Okay. So can only test this on .NET 5 and above, it seems. So we need to say, I think I have something similar. I have a déjà vu. Let's have a look at my director.build.targets. I defined here already a constant that has generic enum get name if it is at least .NET 5. So if it is .NET 5, let's also define another constant. The has generic enum is defined. And let's use that here. So if is this generic, is this constant defined, then we run this. Okay. Let's close this. Continue. Let's close this. Okay. So on, if we would have it available, then it would compile. Okay. So let's assume it's there. And let's check if the system boolean should be the same as the generated one. Let's see if the tests are actually working. Let's do a one should be two. This will fail. Let's set this directive and have a look if the tests are, if we have the test failing, if it's actually hitting that assertion. It does. So we have expected value to be 2, but found 1. So our test works. And what we can now assume, yeah, this should be the same. And let's also do another test where we, because I'm not entirely sure about the flags behavior of the is defined now. Let's see how this is doing for flags. So if we actually combine it. So if we have, let's say we have either put it on method or on class. And now let's, in our case, this would be false. So actually here I can assume value should be true. Still no should be true. So because, my bad. System value should be true. I'm not entirely sure what it's done here. So I generated That one should be false at least, but I'm not sure about the system. But let's find out if they're doing the same. Let's remove that to have it only run on .NET 6. Run the tests. I would hope now that, yeah, all of them are passing. Okay, so if we have a flag combined, in that case, what would the value be? We have a method which is 64 with class which is 4. So if we logically combine them, then this is 68. But there is no constant defined with 68. So this is not defined. If we actually want to find out if a flag is set, then there is a has flag member. So we could check value.has flag, and we pass in a method here. So this would be true. But if we say has flag assembly in this case, this would be false. Because here we have both method and class, so this adds up to 68. But assembly here is not part of this bit field, if this is the correct term. But method is. Okay, so we can. Okay, we know that this should be false of the system, and both of them should be the same. So our implementation seems to be actually behaving just as the system enum is defined. Just to be sure, let's run it one more time. Excellent. And I guess the benchmarks are done by now, and they are. And let's zoom in. What do we see? We have on .NET 5, the generated version takes 1 point something nanoseconds. Again, it's not about the number itself, but about the ratio to the system one, to the generic solution, which works for all of them. The one we built only works for log values. It doesn't work for anything else, for log level. And yeah, so it's faster by a factor of 16. So that's cool. It's still nanoseconds. That's a micro optimization, but perhaps this could be used in a very specific use case. So let's build this. Let's build this generator. And on .NET Framework, we have a similar thing. So okay, tests confirm that it makes kind of sense to generate it. Cool, and let's get started with a generator. Jump to the generator project. Okay, there's now some more files adding up. I guess I will need to do some restructure to give them more a more logical structure to it. So I will just add the new ones in the structure, and then later on off stream update the others to fit that structure as well. I will do an enum info namespace here where we have all the enum info related generators. In our case now we have an enum info is defined, or perhaps, yeah, is defined generator. It doesn't need to be public. We can make it internal because it's a Roslyn component. It doesn't need to be referred to by any user code. But what we do need to do is to add the generator attribute on tab so that the generator driver actually can pick it up. We will derive that from incremental generator. Those are the ones, if we have a look at the help pages, go to the documentation. This is the one added in Roslyn 4. So this is .NET 6, oops, .NET 6 and above. And we will implement this one single member, the initialize method. Okay, I guess this is enough already. Let's do nothing here. Add a nice to-do comment because we need a test. Let's go to our test project. Mimic the same folder structure, enum info, and have in here a new class, enum info is defined generator tests. I will cheat a little and copy some of the setup code that I have already for the other enum generator because it will be rather similar. At the bottom I have some, where are they? Here they are, some verify methods. We will gonna need them, and the rest we can build a new. Yes. Do we need that for now? We don't. Don't do overflow checking. Perhaps we need diagnostic. Oh, we don't need them for now either. This should be fine. Now this test needs to derive from, I totally forgot the name of how I called this type. Let's also have a look at the previous implementation, the other set of tests. It's the, oh no, it's not. Oh, that's actually a static method. It doesn't need to be derived from anything. We just need, I like one method. That's the big one. Okay, let me copy this one over here as well. I will not be using all of it. Let's get rid of the other, for the other generator, we had some checks with overflow, depending on the project settings, if overflow checking is active or not, but we don't need this for this generator, I suppose. We're gonna need some file name, but we can fix this along the way. We don't have any configuration for now. Basically, I guess we can just directly. How did I do this in the other one? Not entirely sure anymore. I just called direct link to verify. Yeah, guess this should be sufficient. Let's add the missing usings. Here we will add the type. So this is our enum info is defined generator. We need the missing using. Yes. And for this verify method, we need to pass in the source, potentially some diagnostics, and also a combination of the file name and the new version of the source code. So this will be, we have our test code that we pass in via our generated code. This will consist here, of the file name. So basically, because, well, it's not literally a file name. A generator doesn't, per default, can be changed, but doesn't physically put out this file to disk. It's just in memory, but it has some hint name that is then used by IDEs to still show this in the Solution Explorer tree. And the content, but I have some setup here. Let's have a look at this. It's been some time where I add, if the language version is at least C#8, we add the nullable header. So we always add the auto-generated on top to indicate to other analyzers that this file is auto-generated and it doesn't really make sense to analyze this and potentially produce warnings on that because it's generated code. The user can't really interact with it, cannot really edit it. So emitting warnings for these is not the best experience. So always put a auto-generated on top of it. And if we have a C# language version 8 or higher, we can also put a nullable enable on it. Okay, so let's get this file header, and this will be combined with the rest of the generated code. And then we can verify it. Okay, now let's write our first test. The method that we test is basically the initialize method of the I incremental generator. And let's have our basic test. We have some is defined is called, and this generates new source. Or let's say it generates enum info is defined. So we're going to have some input text, which is basically the source code that the user would write. Let's have our code. Let's add a using system on top. This never hurts. Let's have a private, no, let's have a public class, my class. And so we passed in, yeah, so we really pass in the code as a string to the testing method that we have in place. So this is, I should mention this. What we're using here, if I go to the project, is the package Microsoft Code Analysis C# source generator testing.xunit. There is also an end unit and a MS test variant, and this is known as the Microsoft Code Analysis testing packages. So if we search for microsoft.codeanalysis.testing, this is testing helpers. Oops, where is it? This one? Yes, this one. This contains testing helpers with which we can test analyzers, code fixes, code refactorings. We can also, we did this 2 streams ago, we can also test diagnostic suppressors. And now we will be using the source generator packages of this. Yeah, this exists, MS test, NUnit, XUnit. If you go through this documentation, there's a couple of examples how to use this, but basically you give in the string from the user as an input. We have an example here somewhere. Basically put in some original string, and then for an analyzer, you can then expect diagnostics to occur at a specific position. Or in our case, this is similar to a fixer. Now we would not be changing any code, but we will producing new code, and then we can assert if this new code actually has been generated, has been added to the compilation. And deep down, not so deep down, but internally, they're using the generator driver, which we could also use directly to have our custom testing framework. And this is how this is working, is mentioned in the source generator cookbook. All links that we will have a look at, I will add to the discussion later on if you want to review some of them. So this is the source generator cookbook, and somewhere it mentions the generator driver. Okay, here's also a documentation how to test. This only mentions how to test source generators. We learned in the last session what we need to change. It's just 2 changes that we need to be aware of. So we then can test incremental generators with this package as well. Yes, so here is an example how to use this package. And also there is an example of if you don't want to use this testing package, but basically want to do it yourself, you eventually end up using the C# generator driver yourself. The generator driver is getting in the the syntax tree of the user code and then producing a new syntax tree, an additional syntax tree, the generated version, or multiple syntax trees. Okay, so we are setting up our test. We pass in the user code, public void my method. Because I only want to generate this enum info2, this new this new is defined method for enums which are actually used. We could technically go through the semantic model and retrieve all available enums and then just generate it proactively. But yeah, this would be overkill. We should only generate it for what is actually used. So let's say if the user would write enum dot is defined and passes in a string comparison enum. I'm not sure anymore. Let's have a brief look at what this looks like. It's in the, is it not string comparison? String comparison dot ordinal, for example. Is this in the system namespace? Yes, it is. So this should not be generated because that's the enum is defined from the BCL. But if we would, I'll go back to the test that we wrote. Actually, make it. And we would like to use the attribute targets because we call this now enum info. It should be generated for this one. We could also add another one. No, let's like this. And then the expected output generated should be basically what we defined. So we have we will be adding, because we will pass into this method, we pass in the generated code here, then add the file header. So we already basically implicitly assume that auto-generated and if C# 8 or higher, nullable is already set. So that means we can define our method. Let's jump to the implementation that we had before from the test. Here it is. Let's perhaps copy this one. But we would like to, for the generated code, I always like to use, and Microsoft is doing this too, in the generators that they're currently available for in .NET 6, the logging, the logger message generator and the JSON system text JSON generators. They are they're not using usings in the generated code. They're always referring to the global namespace, just to ensure that there is no user some user generated type now overriding some of the or changing some of the behavior. So let's go global oops, system dot attribute targets. We will be adding this global system targets to all of here. I hope I know this shortcut. Yes. Boom. Okay, cool. And yeah, this could be the generated code. Let's copy that. Or this could be a good start at what we expect and paste it in here. Now it's just enum info. And let's make an internal. And I guess this looks good. So this would be something that we can now expect. Perhaps let's do the other way around. I will use the string comparison for the one that we expect and the attribute targets for one we don't expect, so that we can shorten this just a little bit. That means I may go to the other test that we wrote. Add the global here. So this is global system dot not system. This is in the Microsoft dot extensions dot logging namespace, and from the Microsoft extensions logging dot abstractions package, I believe. It here as well. So let's expect this one. Okay, let's exchange this here. Internal enum info. Oops, I now have this twice. Okay, like so. Okay, cool. Yeah, let's see if we have a failing test. Let's go to the unit test tab. Let's have a look. This would be tests. Let's run for all the enum info tests. A cover. Yeah, let's have a look at so that we have code coverage as well. Perhaps we enable continuous testing so that we can test with every save of the file. Okay. Let's go to cover new and outdated test. Not sure what my settings are. I think on save. Oh, on build. Let's do. Should we run it on save? Let's run it on save. Only projects related to the continuous testing session. Yes. Okay, great. Now we have green here. Okay, because we're not doing anything just yet, so we need to call our verify. We await that. Await verify async. We first pass in the code. Then we pass in the generated or the expected generated version. And optionally, we could pass a language version. Oh, this is C#. Let's assume this is C# 10. Ah, yes. Did I forget the namespace? I did forget the namespace. I didn't put the namespace here. Put a namespace. So far, I believe I used f0.generated. And now I'm using the C# 10 file scoped namespaces here. So this is definitely language version C# 10. And wait, because we need to make this one async. So this is async task returning now. What you also notice, although I use task here, but I do not have system.threadings.tasks included because we're also using implicit usings in this project. Okay. Now the tests are running and hopefully turning red. Yes, we have a failing test. Because we expected the test state sources to match, but with the test generated contains 2 documents. So we expected 2 documents, but only found 1. This means that there has no source been added. No, so the generator didn't generate anything, which is correct because we haven't implemented it. So we have failing test. We have all the reds here. Excellent. Now we can start. Okay, context dot. Let's see what we have available. Maybe let's have a look at the. Let's jump into the documentation. We have several providers here. Those are interesting to build our pipeline. We will expand on this how we as we go along, but we need to start with the syntax provider. Let's jump back to the source, context.syntax provider. So the syntax provider is the bit of an exception of the other value providers. We are basically building our own value provider with create syntax provider. This takes 2 parameters, a transform function. Also, maybe I should start with the first one, a predicate, which gets in the node where we can do a syntactic check and then return true if this member is, or if this node is interesting to us. If you remember, this is very similar to what the isyntax receiver in an I source generator, the 3.8 version of source generating, um, would receive. So we basically return a true or false if this node is interesting. And if it is interesting, then we can pass in the transform method, where we basically then return t. We can return any t that we want to, that our value provider that we create should produce. So let's pass in a syntax provider predicate and the syntax provider transform. Let's generate this method. We can make this static. Let's return an object just for now until we see what we want to return. And the predicate, the bool returning. So we will get in a syntax node and also a cancellation token into the filtering. Now we need to find out which nodes are interesting to us. So we get in here a syntax node. We get every node of the tree in here. A tool that I always like to use, because I always forget it, is Sharplab. To be more specific, Sharplab's syntax tree visualizer. If I have this very raw example here, and I go to the result drop down and get myself the syntax tree, then I see how the source code on the left hand side will look like from a Roslyn perspective as a syntax tree. We have a compilation unit. This compilation unit has a using directive. This is our system here. It also has a class declaration. Now, if you expand this class declaration, the class declaration consists of a public keyword. It has the class keyword. It could also have a struct keyword, but then it would be a struct declaration. We have an identifier. It's in this case the C. If we expand that, we see we see that C is the identifier. Maybe let's call it my class, because now we see that the identifier is my class. And we have really the entire token here. We also have the open braces and the closing braces. And if we jump more or dive deeper into the tree, we then end up with our method declaration. And eventually this method declaration has a body and could return in this body enum info dot is identified, is defined. And we could pass in an enum to that. String comparison dot ordinal, please. Yes. Cool. Let's have a look how this tree looks like. Okay, well, this doesn't compile because this type is not defined, but we still get a tree. It's valid C#. And let's have a look. Okay. So what's now the most interesting part of it? We have here the method declaration. Okay. The method declaration has a parameter list. There's the body. So I was looking for the body. So having a look at the body, and the body has an expression statement. And the expression statement has a simple assignment. This is this one. We don't care about this just yet, because doesn't necessarily need to be an assignment. We could also pass this directly to a method. And we could have something like private void my method where we pass in the Boolean. And then just put it in here. Now we don't have an assignment, so the assignment itself is not yet interesting to us. Now I lose track. Okay, there is the simple assignment. The simple assignment has a left, the identifier name, which is in this case the discard, and the right is the invocation expression. And invocation expression, that sounds very promising. I believe this is this entire node here. It consists of a simple member expression, a simple member access expression, which is, I guess, this is defined here. It also has an identifier name, enum info, that is accessed via a dot token. We also have the dot in here. Everything is in the tree. And an identifier name that is defined. So this would be the interesting informations, actually. So we can search everything which is an invocation expression. So just from a tree perspective, if we disregard the semantic model, where the semantic model says if this enum info is indeed the one enum info that we are generating and not some other enum info, which could look totally different. But for a first filter, from a tree perspective, this looks promising if we have a look at all the invocation expressions and check. No, if the expression is a simple member access expression, we can check that the identifier name is enum info, and from the expression and from the identifier name of the name here is defined. We could also check that the argument list allows only one argument, because if it has no argument or two arguments, it isn't subject for our. It's not a candidate. That's the word I was looking for. It's not a candidate. And I guess this would be the interesting information that we can filter. Okay, so let's do that. Let's write return. And we check if this syntax node is an invocation expression. The invocation expression syntax. Additionally, we will do pattern matching in here now. Additionally, we can check, let me jump back to SharpLab, that the expression, hold on, there it is, that the expression of this invocation is a simple member access expression. Expression, simple. This does not exist. Maybe is this maybe a private type, the simple member access expression? Let's go to Roslyn, source roslyn.io, which is a source browser for Roslyn. Basically, the Roslyn counterpart to source.net. And this is source.net, where we can browse, where we did previously browsed enum.is defined, if I would write it correctly. But in the Roslyn source browser, we could have a look at the simple member access expression. If this type exists, simple member access expression. Doesn't seem to be a member actually. Okay. So I'm not sure what the member is. Maybe I'll leave this for now. Maybe we can find out. I will do some debugging and see what we actually have. Invocation. I will set myself a breakpoint here. Oops. Breakpoint, yes. Let's get it to compiling. Returning object. We pass in a context and also a cancellation token. This should compile. Now we could debug our test. and hope that we jump in to the breakpoint. I will disable continuous testing for now. Is this still running? Debug? Are we not jumping into? Okay, because it's still not doing anything. Yeah, we're just. I believe I need to actually execute this thing because we're just building up the pipeline. We're not. It's basically like a not a task. It is not a weighted. This is not fitting, but in an enumerable, which isn't. What's the term? It's not lazy, but a deferred enumerable, which isn't enumerated. So it's just it's waiting there for enumeration. So let's have our syntax provider here. I think we need to collect it in order to actually run the code. Perhaps we need more. Let's finish the example actually. So what we also gonna need is at the end, if we want to really produce some source, we can say context dot register source output, where we pass in our value provider and some callback. Generate source. Let's create the method for that. Add it at the bottom. Oh, I didn't compile. That explains why it didn't work. And here we do nothing. Okay. Now I hope we can jump into. Yes, once I. It just didn't compile. Don't jump into this breakpoint yet. Maybe let's. I think I need to collect it, don't I? And this is now the mutable array. Okay. We have a mutable array of the objects. Now I would hope to actually. Or maybe there's something wrong with the test setup. Maybe we really don't hit this code. Let's debug this test one more time. Yes, now we hit it. Excellent. Okay, so what are we getting in here? Do we actually get something which is an invocation expression? Yes, we do. And let's inspect that. I'm looking for the expression. And this is the member access expression syntax. Okay, this is what I was looking for. It's not the. Okay, so the simple member access expression, it's the. I already forgot the name again. Damn it. Expression. It's the member access expression I was looking for. Okay. So we can now check if this expression is the member access expression syntax. Okay, cool. Now what else can we check? We previously said we can check the arguments. Let's have a look at the tree again. So we have an argument list. Okay. Argument list. Oops. Is it not in here? Argument list. Oh, yes, I need a comma here. I'm doing pattern matching wrong, aren't I? Oh, yeah, I'm not in the pattern. My bad. Down there, this is just the if. Sorry. Yeah, this doesn't work. I meant to do it down here. This was just a debugging if that we have. There we have now expression. Yeah, if the expression is member access expression. So now there we are. And the argument list. The argument list has one argument. How can we check if the argument list has only one argument? Let's jump into the source code of what argument list is. It's an argument list syntax. And the argument list syntax has a separated syntax list with the arguments. So we can say argument list dot arguments, and this is a separated list. I believe this now could have a count. I read only list. This is a count. Excellent. We are going to check if the argument list, or of the argument list, now we can use the C#10 improved pattern matching where we can say dot in here. Previously, we would need to have another block and then so argument list, and then in here have arguments is, and then in here, I believe check if the count is 1. But now with C#10 is right of having a simplified property pattern, excellent. But it doesn't work. Not sure why, but we can do it manually. Dot arguments dot count is 1, so we can do it in just one line. It's meaning the very same. It's just improved or a new C#10 syntax of how to pattern match nested properties. What else do we want to check? I think from argument list, that's cool. That's basically what we can say from having a look at the syntax tree, because the name is quite meaningless. We won't know if this is any enum actually or not. But we still should check the names here in the expression up here. And we have a expression, yeah, and the expression has an identifier which is enum info. So the identifier. Expression. This is another expression. Okay. Expression. This expression is an identifier name. And this expression now has an identifier. And if this identifier is enum info. Oops. Enum info. This is basically our class name. Now, what I realized just now, if we would use an alias for our enum info type, this wouldn't work anymore. Okay, so for now, this only works if we're using the actual name of the static type. It wouldn't work via an alias. Or via a static using. Static usings are also not covered. I have myself to do. I guess this will be a follow-up task to improve that. I'll accept that bug for now. Should also work for aliases. To do should also work for static usings. Perhaps this is already the content for the next stream or so. And I want to check the well, I can check the identifier, but the identifier, let's see what the identifier somewhere has a name that we could check. So identifier is a syntax token, and the syntax token somewhere should have a string as a language. There's a value text and text. I again forgot the difference. We had this two streams ago. I believe. Let me quickly find out what the difference between text and value text is. I proposed a PR in one of my projects. That's fco.analyzers, where we're exactly having this. Let's search for value text, or is it just text? No. Oh, this was not. Was this here? This was not in the suppressor. Never mind. This is in. It's already checked in. That's in the. In the record analyzer, isn't it? That's a diagnostic implicit record. Yeah, it should be in here. There we have it. Okay, we're using value text here. But why? Let's have a look at the tests. Source tests, analyzer tests, diagnostics. Here they are. Somewhere I have the at. Yes. So, okay, if we write, so the doesn't include the at. What we see here at location 9, if I would, because in C# I can't use, for example, a while or bool as an identifier name because it's already a non-contextual C# keyword, which is basically a keyword which has been existed since C# 1. But if we would like to use a keyword for an identifier, we could write an at before to basically escape it. And then if we would use in the syntax tree, if we would use text, text would include the at. This would be at bool, for example. But the value text that we're using here does not. It's just bool. We see it here. We have here position 9. We do say, oops, let me zoom in. Position 9. We do have an at here, but the message puts out only identifier without the at. So value text does not have the at. So in our case, if the user would write an at, I guess this should still work. So let's do the value text. So the identifier, actually, use C#10 again, value text is enum info. Okay, so we have the left part, but what's the right part? That is defined. We also want to check that. Let's jump back to SharpLab. There is defined. So we have in our expression, we also have a name, which is an identifier name. So in our expression, we also have a, we also have a name. What type is name? Name is of type simple name syntax. And what's simple name syntax? Simple name syntax is a name syntax. And the name syntax is a type syntax. And the type syntax is an expression. And I guess we now go back to syntax node eventually. Yes, so this is also syntax node. Of course, everything is syntax node. So we should also be using, but I guess here we now could use, there is no really, there couldn't be an at here. I believe this is not, is it? No. Let's see. Can I write at here? I believe I can't. Yes, I could. Was not aware of that. Okay, so again, we will be using value text. Name.valueText is not available. Mm. Ooh, identifier. Yeah, okay, I was on the name. I should have checked the identifier, my bad. So we can say name.identifier.valueText, there we are, is defined. And this should be a pretty good filter. Let's get rid of this here. And now we only get candidates which have the correct name. They need to have the correct name. At a later stage, we will also improve this for aliases and static usings to work. I believe then we need the semantic model actually. We would have this available down here. So we could now check via the semantic model if this is maybe really the type. But then we need the post initialization step for that, because the type already and the method already needs to be partially defined. Yeah, I guess this is content for separate session. I will create here GitHub issues for that, and we will tackle this at a later stage. Okay, now we have the filter. So we know everything that we get here in this transform. We don't get every single node here. We just get, we can assume that this is an invocation, that the context node is the invocation expression that we filtered up here. And now we need to find out what we're interested in. We are interested in, let's jump back to SharpLab, in this name now. Not this name, but this node. Because this could also be, well, we can write string comparison here. We could also have system.enum, no, not just system.string comparison. But we could also have it like this. We have system comparison, string comparison value here, which is, and then pass it here. So we don't necessarily have the type information just from the syntax tree yet. But we have the semantic model. We can now basically check that. Yes, but noticing that we are already 1.5 hours in, I will do a brief break and I will be back in 5 minutes. And welcome back. I realized I previously failed the potentially perfect opportunity to say, I'll be back. But okay, perhaps next time. um, where were we? Yes. So we have filtered the potential candidates for our invocations of our method that we would like to generate. And we basically can now return this thing because on this invocation, there's not really any more filtering. Well, as of now, perhaps we could change this later on, but for now it's cool. We can return this expression syntax, invocation expression here. Okay. Now we can go into the generation step. So we now change this, which means, okay, we first create our syntax provider, collect the elements into a single immutable array in here. So because the here the after the with the syntax provider, it's an incremental values provider. But if you collect them, it now becomes a incremental value provider, where the t is an array of whatever it was before. In our case, an array of invocation expressions. If we jump into our generator source here, this will be now an immutable array of invocation expressions. We get in here our context, we get in our source here, and let's produce some source code actually to see, perhaps this helps later on with the test. If we say context dot, because we're now in the generate source callback, we can now add sources. And when we add a source, we always add, oops, we always add a hint, oops, we always add a hint name. So this is the hint name that could be used by the IDE to display in the Explorer, or it could be used by what we went through last time. By there's an MS build property that we can set that the generated sources are actually put to disk, for example, in the intermediate output file, the obj directory. And then this for those this hint name is used. And we tag in as a string the source that we want to add to our compilation. So let's say, let's call this hint file enum info dot is identified. No, not is. I always say is identified. Is defined. Dot g dot cs. Basically, this is another variant how we can tell tooling that this is a generated file by adding a dot .g. I think also a dot .generate dot .generated here is fine as well. Basically, we combine it both with the dot .g and also the auto-generated attribute, but it's fine to have both. And the actual source that we want to put out. So we have some text here where we need the text. Create source text, where we will actually now, well, we could, there is many ways to assemble the string. What I like to do is not only make all the methods static if they may be, but use the indented string writer, indented text writer, because this allows indenting very, very easily. So this is our writer. What do I need in order to create an indented text? It's a text writer, which takes a text writer, and this text writer, maybe a string writer, I suppose. It's also disposable. So we will write, give it there for some spacing. we will write a using before, and also have a string writer. Passing the writer here. Oops. Okay, now we have a string writer and then the text writer. So this is our text writer. This is our string writer. Okay. Now string writer doesn't need anything because it per default uses a string builder internally. That's cool. Is this also, I guess this is also disposable. Because with a text writer, we can not only write lines, we could also change the indentation. Indent. Indent, yes. So we can say indent plus plus to have the next lines that we produce by one indentation level to the right, or if we do minus minus, then to the left. And we can also set this default what is it called, the default tab string. Okay, by default it's 4 spaces. I do prefer tab, so I will have /t here for a tab. And let's add some source. Let's write line. Actually, let's keep it empty, and then let's see the test failing. So let's return here the string writer.toString. And we will put this text to our compilation. Okay, let's have a look if the test should now create something. Not what we expected, but it should have something. And on the right-hand side, we see that, okay, previously we didn't produce anything. Now we do produce something, but it didn't match. We see a lot of minuses. So we basically see a diff here. So we have nothing, but this was expected. Okay, so let's start generating it. Actually, I can now see what we expect from the test and start adding it. We can have our text writer dot write line. We write the auto-generated line. I need this a lot of times. Perhaps I should make this an extension method at some point of time. This would make sense. Text writer dot an empty line. Then we have another line with the nullable enable. Oops, string of course. Then we have another empty line. Then we have our namespace declaration. This is F0 generated. Cool. And then we define our class. Cool. And now we open the parentheses. What's the singular of parentheses? Parentheses. Oh, it's not that important right now. So basically now defined the class, and in the class now comes what I like about the indented text writer, that we can say dot indent plus plus. I'll do a minus minus immediately as well so that I don't forget it. And we can now start writing our is defined. Okay, basically let's copy this text writer dot write line. Boom. Okay, but yeah, we need to change that. So this is hard coded. Later on, we need to get this from the invocation expression that we now extracted. We need to get out basically this this type here that we can then replace. Okay, then we open up. I again do text writer dot white line opening. It's a brace actually, isn't it? I think in Roslyn terms, I think these are parentheses, then the array ones are brackets, and the curly ones are braces. Okay, so brace is the correct term from a Roslyn lingo. We again, after opening and before closing, indent and outdent. Then we can do our switch statement. Text writer dot white line switch. Again, indent and outdent before the curly braces. And now we have, all of these. So we need to, again, we need the definition so we can enumerate them and put them out. But I already know basically this one, the default arm of the switch expression. We can already add that at the end. But to definitely have a to-do, we need now not sure what the term, but we need this type information here and get all the members of this enum, all the constants of this enum. Okay, but let's have a look if we run the test. I guess I need to do some reformatting here because this doesn't fit exactly. Yes, I need to outdent all of this by 1 and remove this empty line here. Okay, run it again. And we get here always this nice diff. Okay, what's going on here? Not sure, we'll find out later. But yeah, so where we have minuses is all of the non-default arms are lacking. Okay, and I miss a semicolon at the closing of the switch expression. But we expected this. Did I edit at the wrong? We have here the value. Would be this. Okay, but let's take care of the more important one to actually get the constants here out of this enum. Okay, how do we do that? We have available now the invocation expressions. From these, we need to extract semantic information in order to get the type information. So this is an array. Actually, we can another use case that I just remember. Maybe I add it immediately. Perhaps I should then split it up later on in multiple tests. But what if we have this expression here twice? We should only generate it one time. It would be a compiler error if we would now generate the same method definition here twice. So we need to basically get, I don't know what yet, but something, an enumerable of something that we can then feed in to the generate source. I don't know yet. Get something. I will put it immediately into a method. Oops, sorry. We potentially, well, we at least delete the source. This method. Okay. We can now iterate through our invocations. Invocation. Those are our Mutation Expression syntaxes. And what could we get from this? We don't care about the expression itself, but we do care about the arguments. We already know, we could actually assert, debug.assert, that the arguments, argument list dot arguments, this is actually 1. So we could say var, actually let's do it like this. We can say arguments dot count is 1. We can assert that because we did the filtering before in the predicate step. So basically can now access this single one. We can say var argument, we only have 1, is not single, or just get the 1 from index 0. So what's that? That's an argument syntax. What is a argument syntax about? It has an expression. And a name colon. The ref kind keyword. Well, we don't pass it by ref. But from this argument, yes, we need from the expression. Maybe we can ask now the type information about this argument already. We had a semantic model. Not entirely sure, but let's give it a try. We'll pass into this method the semantic, let's not put in the entire context, but just the semantic model of it. It's not the semantic model. It's the, oh no, hold on. Haha, yes, now I don't have it available. We need to add the compilation to our pipeline. So we need to, what we collect here, we need to combine it with the compilation. So in the context, we have a context.compilation provider. And this compilation provider provides a compilation. And when you combine that, now our collection here consists of both the immutable array of invocation expression that we had already combined with the compilation. So this is now, if we jump to our generate source method, we need to change the second parameter here. So this is now a value tuple of mutable arrays, which is our invocations, and also our compilation, because we now have both. We combined it. And so we can pass in the source dot invocations and the source dot compilation. So in this method, we have also the compilation. Okay. And via the compilation, we can get the semantic model where we can ask, semantic questions about this node. So what does it actually mean? Because from a syntax tree perspective, it's basically just a string. It doesn't have any meaning. I could define my own int 32, which is also in the system namespace. The compiler will warn that there is an ambiguity, but technically speaking, and from a syntax tree perspective, we don't know that an int 33 is actually int 33. It could also be an alias or something. But with a semantic model, we can now detect what it actually is, what type it is, not just how it is represented in the syntax tree or in the C# code that the user wrote. And we get, what does the semantic model require? It requires a syntax tree. Um, do we know the syntax tree here? Yes, we do. So this, the argument or the node knows in which syntax tree it is in. And here we now have our semantic model. And with the semantic model, we can now get type info, I believe. Ask now what this type is. There is a bunch of overloads for get type info. And yeah, so ours will be most likely the syntax node here. So let's pass in this attribute, this argument, and see what this type info is. There is now a dot type to get the type info. It's actually now a type symbol. And I'm not entirely sure what this is. So let's have a look. Let's return null here. Let's have a look what we got here. Let's do breakpoint and run the test. Or debug the test. Type info is null. That's unfortunate. I'm doing something wrong here. I guess I don't need to, I can't pass in the entire argument. I'm looking at my cheat sheet right now. Hmm. Okay, we need to use the expression from the argument. So not the argument node entirely, but just the expression of it. This should now yield the result that we are expecting. Well, not sure what you expect, but not null, still null. Okay, not entirely sure what I'm doing wrong. Not yet. But we do have here our invocation, and our argument is, that looks good, string comparison.ordinal. That's cool. But now we want to get the type of it. New model, get type information. But this is actually null. What's the result of that? Non-error name, but it is not null. Okay, not sure what I was doing wrong. Maybe, is it because of scope here? Is it already out of scope? But it is a non-error named type symbol. That's cool. So I will assert here that this is not null anymore. Type symbol is not null. Otherwise, perhaps we had no type information here. And this type symbol, now we should be able to ask that what constants it has in order to get the constants from the enums. I'm looking at my cheat sheet. Or we can do that So we can ask, okay, so this type info actually has a type. And we can ask that this will yield the type that we require, okay? Previously we saw non-error. Perhaps we should also assert if this is not AI error type symbol. We could say that argument yielded an error type. And the type symbol has a type kind. Yes. And this one is an enum, which has all the type kinds. And I believe there is an enum. So here we can check if this indeed really is an enum. So we can say if, should we, perhaps let's be a bit more aggressive for now. Let's just assume it, let's not be, let's be defensive. So if this is an enum, if this is not an enum, then we can continue the loop. We don't want to analyze any non-enums here. Perhaps the user passes in a 1, then this wouldn't compile because this method shouldn't be generated, or passes in a string. An enum needs to be passed in. And from that enum, and now I guess with this type information, we require that in order to iterate the constants of it. So we could add this to a list of type symbols called types. Types.add this type symbol, and let's return these types. So we have type symbol here, and now we have our types here, and we can pass these to the method which generates the source. And now we could iterate this. Actually, we can. Where's our hole? Here's our hole. Here's our to-do, where we for each now these types. And for each type, we need to basically generate something like this, where we have on the right-hand side of the switch of this arm a true, and on the left-hand side this identifier, the name, could be global dot colon something. So we need to extract. Hold on, is this correct? This is not correct. Actually, this loop needs to be over the method, because per type information, we want to create one method. Okay, we open the method here. We have our switch. Close the method here, I believe. Oops, close the loop here. Well, we'll see in the test if it's not correct. And have it here. And now in here, we have an inner loop where we now get all the constants of this, or the named constants of this enum. How can we get these? Let's have a look at what we get in here. So we iterate the types, and then from this type, we need to iterate something. I will comment this loop out for now. Do breakpoint here. See how far we get. Okay, what is our type here? Hmm. How does the type does not exist in the current context? Did I? No. Let me run the test again. Is it because it's not used? Ah, there. Now we have it. Okay, cool. So what can we extract from this? Maybe find somewhere a collection of members. Ooh. Ah, okay, this is all interfaces. No, this is what would you search for? Some members that we could extract. Member names. You have a constructor. Oops. Sorry, hit escape. I'm too much. Hmm. Ah, okay. Well, this is just a generic type symbol. Perhaps there is a more specific. No, it's a non-error name type symbol. How do we get the static members out of it? Type dot get members. Ah, okay. It's not a property. It's a method. Let's see what get members is yielding for us. An array of I symbols. It does look promising. Let's debug the test one more time. We hit the breakpoint. By the way, I love debugging with unit test as an entry point. Doesn't exist in the current context. And let's evaluate this expression. And here we have a result of, yes, this looks good. We have our current culture, invariant culture, ordinal, and we have also, okay, we also have, so we have the 6 field infos and 1 method symbol. I guess the method symbol we don't need. It seems to be the constructor. So an enum has implicitly a constructor. Well, it's a struct. Everything is a constructor. Okay. But we only need to get the fields out of there. So yes, now link is in order. So saying select where member is I field symbol. That looks cool. Let's see if this yields what we require. Put it in here. Now I would hope that we got, oops, not bool. What's this bool? I'm selecting. It should be a rare, of course. My bad. Yes. Now it's the symbol. And this could be a field. And perhaps we also need to, could enum have non-constants as fields? Do we need to have some checks in place to verify that this is a constant? But I guess we don't. Maybe later on when we have a unit test or a failure, we can have a look at this. But for now, we check just if it's a field symbol. And now from this symbol, we perhaps could get the name of it, but the full name, like the full global full name. And there's something like to display string, where we can also pass a format, a symbol display format. And with the symbol display format, there is some defaults defined here, but there is like a lot of properties you can set for this to display string, such as if we use the global namespace style that we want, we don't want to omit it. We want to have the full global thing, and the name and the containing type. We don't have any properties. We don't have any generics. No members. No parameters. No miscellaneous. What do we have here? No, this doesn't look. But I guess we could create our own if there is none that fits our needs. This is omitting. This is omitting. Including name and containing type and namespace. Oh, this fully qualified format looks promising. Let's use that. So we go back to our toString, say display format, fully qualified format. Excellent. And that would be our display. And we want to use that for all of our arms. So we now, instead of this underscore, we basically insert the display name here. Perhaps we shouldn't. Now, if this was .NET 6, this would be cool, because with .NET 6 with C# 10 and .NET 6, we have interpolated string handlers. But yeah, so this basically now gets changed. Well, it's two strings, so I think it's a string concat. That isn't that bad. I guess that's fine, actually, to have the string interpolation here. But what I want to say is because it's .NET Standard 2, analyzers are .NET Standard 2.0, so you don't have a string interpolated handlers here. But so the interpolated string will change into a string concat. Actually, not sure. Or is it better if we do a text writer.write, where we pass in the display and then the rest of it in the write line? Yeah, but this should yield true. Now I'm curious about how the test turns out. Mhm. This did not. Okay. So what we see, we expected the global, but it didn't use. It just used current culture. It's fully qualified, but it does have all of the members: 1, 2, 3, 4, 5, 6. And in our expected, we also have 1, 2, 3, 4, 5, 6, 7. Oh, so hold on. I'm doing wrong, actually. I'm expecting the log level, but I have current culture. mm, I didn't finish the thought from earlier because I wanted to have this a little bit. Sure. We don't have the log level here available, yeah. So for the unit test, for this unit test, we don't import the Microsoft extensions logging.abstractions package so that we have the log level available. We should be using the string comparison that's part of the BCL that's in the test as well. Well, we could add it, but I for now rather use what's there already. I got this somewhere, don't I? Do I not? Let's generate it. We want to have a method which has string comparison, and let the IDE create all the arms for us. We have a bunch of trues here, and this would be global system.string comparison. Global. Okay. Yes. And this is what we do expect. Let's jump back to our test. Replace this. And also up here, the parameter. Okay. But still, we didn't have the globals in. So this fully qualified name this fully qualified format does not seem to work, but I'm surprised because it says included name and containing types and namespace. Hmm. I'm surprised. Kinda don't believe it here. Indeed. Growing culture. Why is it? The style here is name and containing types and namespace. And for the global namespace style, we have included. Not sure what I'm doing wrong. Perhaps I'm trying to be naive now and just try with my own. Private, static, read only. Is the format my format? Oops. This new, and we want to pass in as a first. We want to include, and we want to name only, name and containing types, name and containing types and namespace. Yeah, we want all of it. No, this should. Why would this not work? This doesn't make sense. Doesn't make sense. Should be the same. It is. Why do we not get the global identifier here? Okay. Here's also still an issue. Maybe this works different for constants. Maybe this doesn't work for constants, but for type information. Perhaps because the enum name is not it's contained in a type, not in a namespace. Maybe that's why. But again, another problem is here. Still hard coded. This should be. I will split this up again into two white lines. We have a text writer dot write first part. Also. And the second part. And in the middle dot write, we put in some value. The type name, the fully qualified type name. How do we get that? Perhaps also from type dot to display string. Maybe the fully qualified format does work here. Let's give it a try. And then we could use that information and end it at the bottom. Yes, this seems to work. I made a mistake. I forgot the value here. Okay. But this seems to work, and let's just use this information. We use this fully qualified type name. We just do maybe just a toString suffices here then. And we have field. Well, let's do another text writer dot write, and we put in that, and we add a dot, and then write the field toString. Let's see if that works. Is my test set up incorrectly? No. I'm surprised that we don't get this here. But I do. Why is this? Something doesn't add up here. Let's have a look. Debug. It is. Global system string comparison. Then we add a dot. We add the field and say true. This looks good, doesn't it? We do this for all members. So we do it for current culture ignore case, for invariant culture, and so on and so forth. Maybe I didn't save or something. Okay, now it looks better. Okay, cool. But we still have a diff here. Ooh, because I have system here, not I have system. This contains system. Okay. So we do need to have here dot to display string. Let's see if the default format suffices. Does not. I was never using the what do you call it, format again, because that did what I wanted previously. I need to compile first. Okay. Now it looks better, doesn't it? So we have. Okay. Ooh, now we have it twice. Or we see now that we actually have it twice. So the issue is we create this string comparison method twice because we use it twice. Which means we have the invocation twice, but we should only generate it one single time. I also missed here's a space missing. So we need a way to, when we extract the type information, we need to check if this is already existing in this collection and only add it once. What I like to use is a hash set here. And then pass in, we get a warning here. This is a warning from the, if it is, I believe, yes. Use simple equality compare when comparing symbols. This is a warning from the Microsoft Code Analysis analyzers. So those are analyzers for writing analyzers and source generators. And we should be using a symbol comparer here, simple equality comparer. I believe the default is fine here because we don't want to compare them by reference. So we have this simple equality comparer. And we add, so this is actually now returning a Boolean, but we do not care whether it has been added or not. It should only add it if it's not there yet. So this should filter out all the duplicates. Run the test again. And we have it now still twice. Do I need to build again? I guess I need to build again. Seem to be have my issue because I already know. I didn't mark the Enum. We now have two generators which generate Enum info members. All right, Enum info methods. Actually, Enum info classes. So we do have the same type twice. We need to declare that as partial in both generators. But this is then the compiler error that we have. Also the compiler error for the actual generated code. But so for the unit test, we are actually pretty good. If only here something is here, we are missing a white line here. That's it. Not green just yet. Oh, okay, I need to build. Run it. Okay, there is something wrong with the formatting or with the encoding, but the source text is fine, so that's cool. I will now go ahead and fix this one issue that our generator should create, because we have another generator which creates a enum info type, which is holding the member for the faster get name, or the generator get name. So we need to declare this partial. Now also in the unit test, expecting, of course, to be partial. And also the other generator, the enum info generator that we have already, now needs to, where is it? Static class type name, there it is, as partial class. I will fix all the tests that I have for this later on. They will fail now, but just to get it compiling again. Looks good. Looks very good. Excellent. Cool. Okay, something wrong with the format. I believe in the test I expect UTF-8 without bomb, but I think I will using with bomb here. The byte order mark of UTF-8. That means we jump to the generator, scroll to the method where we actually emit the code. Yes, so the add source also allows a source text overload for which we can we create this? We can say from text and the encoding. So rather than directly a string, we wrap it in a source text. So let's do that. We have here source text. No, source text from that's string, and we do. I think I have this somewhere already. The UTF-8 without bomb. How do I call it? No bomb or something? UTF-8 no bomb. I have encodings dot UTF-8 no bomb already. Encodings. This is from f0.text, yeah. No bomb. Okay. Let's run the test again. Not green just yet. No, it's the hint name, which is now not correct. Or the file name. Yeah, the hint name. So what do we expect? What do we create? We create enuminfo.isDefined.g.cs. I believe I have this wrong in the unit test. We expect this should be type of enuminfo is defined generator. And the name is, so this is basically the path how this hint name is working. And here we have enuminfo.isDefined.g.cs. This should fix that issue. What's next? There is no argument given that corresponds. Now we have a compiler error. Enum is defined. Okay, so the generation looks good, but the end result has a compiler error. I believe this is only an issue with the test itself, but not with the generator anymore. Yes, this does. I need to make sure that we are on .NET 6 actually. Maybe this is not using the .NET 6 reference assembly. I believe I have an overload for that, which takes the reference assemblies, yes. And for the reference assemblies, so we can pass a language version. Let's do C#10 for now. And also the reference assemblies, and we will pass the from .NET, .NET 5. I don't have .NET 6 here yet. I believe I need to upgrade my test project. But I am using, okay. I'm using, because these reference assemblies, they come from the Microsoft Code Analysis testing package. Maybe they exist in the latest version. There is a 1.1 already. Let me update to that. I saw this while preparing a bit for this session. So this one exists already. Maybe this one has the .NET 6 reference assemblies. It does. So let's pass these because they contain the enum info, the generic enum info. So what's next? No, this did not fix it. The name enum info does not exist in the current context. Okay. The issue now is that in the unit test, I do refer to enum info here, but it's in a different namespace. I must add using f0.generated in. What's next? If there is anything next. There isn't. Yay! So the .NET Framework test is green, and when we run it for .NET 6, both tests are green. Yes! Woohoo! We built our generator. Well, there is quite some corner cases which are not handled, but I will then mark them, lay them out in with to-dos, and then fix them off stream. You could have a look at the pull request if you want later on. But first, let's now see this thing in action. Let's jump to our example project. We have here samples, and already have some samples here. So let's have a look. Let's do a new white line here. So here we basically test the other generators that we have already in the assembly, in the generator. So let's have another one. We white line enum info. Because what we see now, if I do F12, this one, yeah, this is not a partial, it should be partial. Perhaps I need to rebuild. Is defined as not available just yet. Maybe after a rebuild. Or do I need to restart the IDE? Perhaps I do. Perhaps I do. Let me, maybe it suffices to run it again. Maybe just to be sure, I also build the project via the CLI beforehand. I think this will be, I read through the early access release notes of Rider, and there was something noted that in some generator use case, the Rider doesn't need to be restarted anymore. This should be fixed in the next version, or at least it mentioned somewhere. So maybe this is exactly what I'm facing here. It would be awesome. So if I build now, perhaps we now have our is defined available. We still do we do not, because I do not generate a stub. For the other one, for the get name, Okay, what you see now, this thing is now partial. Um, what I did for the enum info is actually create a stub for it. So a method which takes any enum and then throws for IntelliSense. So this is basically an IntelliSense convenience. And then we have the specialized version afterwards. Because now I need to know how this is called. I need to know already this is bind and to pass in our string comparison dot ordinal for it to be picked up. Is now maybe another ID issue because it says build succeeded, but we have red here. So let's run the sample. If I select the example and I run it, it runs, and you get the true. Let's do another one. Let's do the attribute targets. Attribute targets dot method. So this should also yield true, but if we have like flags, like attribute methods and class, the same use case that we had before, this should yield false. So let's actually make this a little bit. Let's put this into a interpolated string where we have string ordinal. We could do, let's leave it like this. Here as well, concatenate string. It's a interpolated string. Method goes to and one more. Interpolate with that goes to. What am I doing wrong? I did it outside of the quotes. Okay, let's run it. And there we have it. Oops. So string comparison ordinal is true. This is defined. The method is defined. But if we combine the flags, this is not defined. But actually what should be defined again, because we do have, I think there is an all target. There is an all target. So if we basically add all, if we basically would do this, then it again should yield true. If we say all here. Okay, it is now a bit cumbersome, but let's see. I just paste it everywhere, add all of them by hand manually. Because this now should be the very same integer that the all constant is defining. And this should be available again. So we should have true, true, false, true. And we do. True, true, false. And when we define all, it's true again. Excellent. What did I? So yeah. So IntelliSense would be nice, wouldn't it? So we can go to our generator. Now, of course, first we go to the test. So what we also want to generate, somewhat unconditionally, we want to generate a bit of a stub, which should actually never be called, because when we call it with something which compiles, then a more specific version is generated. So let's throw here, throw new. I do have a global. There is another generator which generates an exception that is specifically meant for source generation errors. So I could say f0.generated. I forgot the name of it. It's the source generation exception. And we throw that one. This should not occur. And we pass in here a system.enum. Is this a class? This is a class, isn't it? System enum. So I guess we make this nullable. No, it's not. Sure. let's make it, I think I have it nullable in the other one, so I make it nullable here too. And yeah, so this could be the stop for IntelliSense so that the user knows what to write, and then it gets replaced, not replaced, but overloaded with a more specific one. Let's see the test failing while we go to the implementation, and we'll add that as well. Test is failing indeed. This one is missing. We are going to find here's the class. So we just need to define another method here, another is defined method. Actually, we have it already. Let's take it from the test. There is no conditions here to be met. So we can say textWriter.write line. Did I zoom? Ah, so I lost the zoom. Sorry. Here we go. Oops. Put in this one. 1, 2, 3. We have a opening brace. We have a closing brace. We do indent and outdent, which is ident minus minus, and throw this exception. Cool. If I build, maybe the case that we don't see it immediately because again need to restart. Also, actually, see the test. I'm missing one new line. Well, this is formatting. This could be like, this need to be pretty formatted actually. This the string that we output, but yeah, I kinda like it. Just needs to be valid C# that we add to the compilation. So do I need to build again? And then run the test? Okay, the issue here now is that we write this line indented, so I have an empty tab here, an empty white space. I think I have an overload here already, white line and no types. Oh no, this exists on the stream writer, doesn't it? No overload needed. But it does have it requires a string. I think I have an extension method for that, don't I? Yes, this one. Yes, okay, cool. And do I need to build again? But if I do, let's build. And let's run the test. Okay. Now we have, there is no argument given that corresponds to the required formal parameter of message. Okay, because I didn't include, generators are not depending on each other, and especially this unit test does not execute the other generator which generates this source generation exception. So I need to add this manually. So we'll go to a place where I already have this. So this is how it actually looks like. If I F12 this is what the exception looks like. It's also generated. So I can basically, I don't need all of it, but let's for now copy. I need to add this as additional source. Let's grab this. Let's for now, I will add this for myself as a to-do to use the more specific exception here. I would like to do some refactoring there. So for now, we'll just use system.invalid operation exception. And a passing to do here. To do so that I don't forget that I actually want to replace this. Okay. And in the unit test, we expect that as well. Because the invalid operation exception, that's part of the reference assemblies that we add for this test. So these are available. System.invalid operation exception with a to do. Double quotes because this is a string and verbatim string. Let's build and run the test. So this was a compiler error, but not a generator comparer, not a string error. So it's time. Yes, looks good. Excellent. Okay. So we now should have IntelliSense. I guess I need to restart one more time. I will briefly close the E. Fire it up again. Let's go to our example. See. We hopefully now have IntelliSense. So if I would remove all of it, comment it out, and I would now say enum info dot. It's still not there. Not entirely sure what I'm doing wrong. But I guess if we would do like a white line and actually call it with, I call it with null, and this should now call into this new basically placeholder. So I would now expect a to-do exception to fire. No, it doesn't compile. Does it? Was this terminated? Uh-oh. Does not look good. Okay, no, this does not. Does this generator? It seems that the generator is crashing now. Ooh, because I passed in null here. This is not a valid. This is something not valid. Guess I need to, in the generator, when we extract all the symbols, the type symbols, when I pass in null, does this mean maybe the type symbol is not, maybe we're hitting something here then. Let's add a test for that. So we also would like to be able to do this as in null into the enum info. Dot is defined. And let's have a look what will go on in our generator. I believe something in here will be not working. Yeah, so the issue is we expected 2 sources, but we only have 1, which means the generator doesn't produce anything. So we crash somewhere in here. And so what is the type symbol? I suppose it's here. Is it null again? Is it actually null? It's null. Okay, fair enough. So we cannot safely assume it is null, but if it is null, if we have no type information, well, then I guess we can also, if type symbol is null, Or if the type kind is not enum, then we continue the loop. Writer suggests to write it like this. Fair enough. Let's run the test. Still not passing. Still crashing somewhere. Ooh, because it is an arrow type. It seems to be, when it's null, it seems to be of arrow type symbol. So let's also, if this is not an enum, and let's check. Okay, now I believe I need to split it up. So if the type symbol is null, or if the type symbol is not arrow type symbol, or if the kind is enum, not enum. Now we should have them all. Let's refactor later. Let's first see the test become green. So we check if it's null, we continue. If it is of arrow type symbol, we continue. And if it's not an enum, we continue. Now it turns green. Okay. Now we refactor, merge into one. If it is null, or ooh, I like that. That's the C#9 and so in C#9 and or combinations are added to pattern matching. Cool. Okay, we fixed that. Also have a test for it. So we have fixed this permanently. Do I now need to restart the IDE one last time, perhaps? Let's give it a try. I will restart one last time. Boom. And let us build the solution. We still get the, ooh, now we have no more errors. Okay, cool. Do we now have the is defined? Yeah, we now have it. Okay, so we now have, so it's a to-do. I will fix that later. But we now have the IntelliSense available. So I could write enum, even if none existed. Actually, let me open this generated file in the second tab. Close all of this. And if I would happen to remove or comment out all of it, now this file disappears. And it's gone again. Okay, obviously in the generation, I somewhere have this step that this placeholder is not generated at all if we have no single invocation. So I think this is an issue how I set up the incremental generators. I need to set up some unconditional generation of the placeholder IntelliSense method. But technically, it's working. I will do this later on because we already almost 3 hours in. But in general, this is working, so we can run it. And we now get this invalid operation exception, so this placeholder thing also exists. But I need to ensure that it's always created. Seems to be an error here. To do needs to be generated unconditionally. I'm most likely going to putting it into the post initialization step because post initialization because this is what's there in source generators. This is available in 3.9 generators, in 3.9 source generators and in 4.0 incremental generators to create something unconditionally where we don't have the semantic model available. I think we have no node information as well. We can basically just output any source. And this would be a perfect candidate to have this stub, this placeholder generated there. Then it's always there. And then actually, this would combine well with the other to-do that we added about aliases and static usings. Because if we generate this stub unconditionally via the post initialization step, it is available to the rest of the generator. Because in general, generators cannot depend on each other. So the output of one generator cannot be used in a different generator. But the output produced in post initialization steps can be used by the later register source output step. And I believe this would be the place, because then we also have semantic information on that, and then we could also have a alias here. We could have using my thing is f0.generated.enuminfo. If I would be using my thing right now here, this wouldn't work, because let's see, I don't expect it to work, because this should now fall back to this is defined operation. So I will remove that call, but we still end up with the exception, or I expect to end up with the exception. Yeah, because now this one calls into the generated stub, which accepts any enum, and then throws an exception. So no special overload is created, because we expect it to be named enum info, but it should be, or it could be, via the post initialization, from the post initialization step generated, and then the generator itself has then the semantic information about this and this my thing, and knows that this my thing is the enum info type that we are generating our enum methods on. But this is this is a nice to do for, perhaps for, not sure if I do it off stream or if I do it in a next session. Okay, now we want to test this. Actually, we do have a couple of tests, but let's replace them. So we have our benchmark. We have our isDefined benchmark. Now I want to get rid of this manual implementation, and use the generator. enuminfo.isDefined. We need a using, and we see that the system enum info is the one from the BCL, and the generated version, oops, I lost the zoom level after the restart, is our generated one, the enuminfo.isDefined.g.cs. Cool. Now let's benchmark this. Jump to the benchmark folder, open a CLI there, .NET run -c minus release. We want to run our benchmarks in release mode. Unused field format. Okay, because I do have warnings as errors in release mode, and I have a warning that problems. Where's my problems page? There it is. Didn't see. I guess it's the isDefined generator. Yeah, this one is no longer needed. The field for the display format. Let's run again. And we want to run our one enum info isDefined generator benchmarks. Go. While this is running, there is more we need to replace, because we also have tests. So this is not tests for the generator itself, but this is now test of the generated code. We can get rid of all of this too. And use the enum info now. I guess we're also lacking a using here. and it's added now. Okay, cool. I bring back this only runs on .NET 6, not on the .NET framework. So let's execute these tests. Let's have a look. Open another terminal here. .NET test. I expect them to pass. Now with we removed our naive implementation from before, but now using the generated version. And it behaves the same. Excellent. We also benchmark, I guess, is still ongoing. Oops. Still ongoing. In the meantime, I could have a look at the coverage. So let's go to tests. Let's go to the enum info and cover selected unit tests. While we're doing that, I also want to run a mutation test on that. So let's jump to the test folder. I'll do this via striker.net. Let's see if I have it installed. .NET tool list, where we can list all the local tools. We indeed have .NET Striker available, so we can say .NET Striker. While this is running, let's have a brief look at the configuration. If it is how I would like it. No, this is not how I would like it. Let me abort that because I only want to test, or I only want to mutate our new generator, not the others, because this would take a little bit longer then. And since we're already 3 hours in, I would like to have a faster result. So I only mutate the enum info is generator.cs. Okay. We ignore debug asserts. If we have them, they don't need to be mutated. We don't have any configure with false, but I still have it always in the configuration. I never have any test which fails if I change the boolean which I pass to the configure array. Okay. Now let's run Striker. See if it is starting to mutate as expected. No, because we have a failing test. Okay. Yes, I need to fix all of the tests now because of the partial. I added a partial. I should have run all the tests, not just the new ones. We added a partial to the enum info generator, but only in source code. I didn't do it in the test. Yeah, I should have done it the other way around. This is now the punishment for it. This is here. This is the other enum info generator. Let's see. I want to have this in one place. Static class enum info. There it is. So basically pack a partial onto that. Does partial exist in C#1? Let's find out. So the tests were failing. Still failing. Static partial. I wrote it the other way around, didn't I? Yeah. Yes. Oh no. There is one. The C#1 version is okay. Well, for the C#1 version, I'll get into that later because what you see here, I also produce it for different language versions. I will add tests for this later because now the generator that we produce, it only works for C# 10 because we are using file scope namespaces. So if a project which has set the language version to .NET to to C# 9 or lower, because maybe it's a .NET Standard project and .NET Standard projects have C# 7.3 per default, then this wouldn't compile. So I will add tests and also then switches to generate. If the language version is lower and a specific feature isn't supported, then I will generate code to be compliant with that language version. I will do this then before I release this in the generator package. So I expect the release to be just before the next stream, so in roughly 2 weeks. Okay, but the tests they should turn green now. And they do. Lovely. Which means we can give .NET Striker a try again, because, well, per default, Striker.NET wants all the unit tests and expects no unit test to fail. Because if one would fail already, then we couldn't confirm that mutants would be caught because we expect failing tests. Yeah, then the mutation one wouldn't make, could have less meaning. But okay, we now see that we only run we removed some by filter. So we only run this one class, so this is rather quick. While we wait for that, we have a look at the benchmark of the generated code, and it is very similar to what we saw before because it's actually we generate the very same code, so this is how it was expected for both .NET Framework and .NET. We have, I think previously we also had like 17, 16. Well, it's again, it's not about the numbers because I'm streaming on the side, and so this is not real good measurement on how fast the method performs. But it depicts the ratio between the generic version, which fits for every enum on the world, and the generated one, which only fits for this one specific, which is generated. Cool. So that's a success. Let's have a look. Mutation test report has finished. Let's open up the report. Yeah, I love to see that. That's a solid 100%. Excellent. Let's have a look. Yeah, we actually killed 80 mutants. That's quite solid. So we not only have 100%. Do we actually have 100% code coverage? I did not confirm that. I need to run them again. Just the enum info cover. Which is here in generator. No, source generators. 0. Code analysis, enum info. Yes, we have 100% for our enum info generator. So not only do we have 100% code coverage, but we also terminated some mutants. 2 have been ignored. Let's see who they are. Yeah, they are both in the debug assert that we ignored. So that's a meaningful report. And really good on the test. And so what are the next steps? The next steps are, let's have a look, open the generated version of the code. To actually, yeah, to bring this, no, I want to go to a sample, to complete this implementation and bring it to production. So I want to release this as a NuGet package already exists, but in a new version. Now, this unconditional generation, so that this also works for aliases and such. I will do not in the upcoming version. I will do this in a future version. Perhaps we could implement this in an upcoming stream. But what I will take care of is the different language versions that it works on every language version. Yeah, at least for C# 2 plus. Well, at least for C# 7.3, because that's .NET Standard 2.0. This should cover the most consumers. And yeah, this I will do off stream and then publish the package. Let's have a look at the agenda. I think we are rather complete. Let's see. We had a look what we did last time, what an incremental generator is, how this pipeline we're building up that we used. We had a look at let me zoom in, of course, at the BCL is defined, the general method that works with any enum in the universe. We benchmarked and tested a very specific variant, which is then with our benchmark here, 15 times faster. It's micro optimization, of course, but perhaps there is a corner use case which could make use of that. We test-drivenly developed this generator and then tested and benchmarked the auto-generated code as well. Okay, I marked it here as a to-do. We didn't get to that, but I will do this off stream to then have switches in place. Perhaps just very, very briefly, how can we find out which language version the node that we get in, or the project, the compilation that we get in is? Via, of course, we are an incremental value provider, because it's not part of the compilation. If you would have a look at the compilation here, we wouldn't find it, but there is also parse options. So what we have collected here, we could also combine this with parse options, use the collected, and combine that with context.parse options provider. Now this will add another thing to this value tuple. Actually, I will create the overload. This is a little bit quicker. Then jump down there, replace it. And now we have our invocations. We have our compilation. And this is now a value tuple, which is nested in another value tuple. I like to call the other one other. And here now we have the parse options available. We have here the parse options. Okay, let's get this to compiling again. So this is now all in the other because it's nested one time. Oh, it's source. Didn't replace that name. Okay. So this is in the invocations are in the other and source are in the other. And context is called context. And we now have the parse options available. So we can say var options equals source.parse options. And these parse options we can ask, for example, is C#. I actually built an extension method for that. If we jump into that, so this takes in parse options and checks if the language is the language name C#, which is a constant, which basically says C#. And another thing that we could do is if we know it is C#, that is C#, then we can cast this parse options into C# parse options. And these C# parse options now have a language version. And that we can get a hold of the language version. And if I would debug into that from our test, where in our test, when you scroll down, we actually state that it should be passed with C#10. We now should, when we run this, also have C#10 debug in this variable, in this local. We hit the breakpoint. And have a look at it. And C# language version indeed is not part of the current context. Let's do it like this. Dot language. Can I do that? Evaluate. No, it's not. Okay. Is it because I'm out of scope here already? I believe it is. Can I do that? No. Okay. We see that I'm not super familiar with Writer just yet, but I will improve every day a little bit. Now we have him. Okay, I guess it was already out of context. Behavior is a little bit different than Visual Studio. Is this possible? Not sure. And if we have a look at them, yeah, we see this is C#10. And then we could have checks in place where we basically say, okay, if I now do some, if our language version, let's assume we have a language version here. Actually, let's pass it in. Let's complete this example. We have our language version here. Let's put this into the block and we pass in the language version 2 to generate source, which means in here we now have a language version, lang version, and we can say if lang version is greater than or equal to language version C#10, because then we can create. Of course, I should beforehand write a test, but I'm laying it out how we could do it. We would, if it is C#10 or higher, we have file scope namespaces, so we can do that. Else, we would write a blocked a namespace and start a namespace block. Then open up the block. And of course, at the very end, we need to close it again. So just before at the end, we now need to say if the language version is lower than C#10, which means file scope namespace is not supported yet. We opened a block there, so we need to close it. And now we also support C#9 and lower. We will now need to have a look at what C#9 code is perhaps some C#8 code. Is it that the switch statement is not available? C#8, C#7, not sure. And have more switches to support more languages. An alternative would be to just produce a C#7.3 compatible string and not do the fancy. If we have a higher language version, use it because it's generated code. It doesn't matter actually. I like to do it, so that's just a personal preference. Okay, and I will tackle this off stream, and this will be then part of the published project to support not only C#10, but I guess I will go down until C#2. Yeah, I will go a little bit crazy there. This is definitely overkill. Don't do this. Yeah, and we checked the code coverage. We had 100%. Checked the mutation test report. We killed 80 mutants. That's awesome. And what's next? So this was chapter 1 of generating faster Enum methods. There is more Enum methods where we could generate very special case implementations, which are only which are then generated for each enum explicitly and then yield better performance and or less allocations. But we will do this not immediately with the next stream. We'll do this at a later time. It will follow shortly. What I want to do next time is actually do a little bit something different. So, well, we will still do Roslyn. We will still build generators, but not per se. We will be building a template. We will be building a template for the .NET New command in the .NET CLI, so that if you would like to start a new generator project, you could use one of these templates then to kickstart your journey. Because there is quite some setup necessary, especially if you want to. If I have a look at the project, if you want to have multi-targeting in order to get nullable annotations and have the analyzers in place, and then some multi-targeting stuff to get it all right. I would like to offer a template for that. And we will build this next time in 2 weeks. And by then, I should have this generator version ready published and the YouTube channel spawned with the recordings of this and all the previous sessions. And this is it for today. I will update probably tomorrow this discussion with all the links that we've explored today to have a complete documentation if you want to look something up. And yeah. Is there something I forgot other than saying thank you very much? Thank you very much for staying a while and listening, either live or perhaps later the recording. Perhaps leave a comment and let me know what you think. How can I improve? And perhaps also if there is a specific set of content that you would like to see, maybe we have a matching interest at some projects to tackle. Excellent. With that, thank you very much and have a great day. Goodbye.